and y. Maybe it curves up. Maybe it curves down. Maybe it curves a different way. All of those lines are possibilities for position time graph. Diego, you look really concerned. Okay. Okay. All of these are possibilities for a position time graph. When you have a straight line position time graph, this means that you have the constant velocity form of motion. When you have a curvy position time graph, this means you have the constant velocity, the constant acceleration form of motion. Acceleration being a vector that we haven't talked about yet. Just like position can change, and that change over time gives me velocity, velocity itself can change. And the way that we describe a change in velocity over time is with acceleration, which will be this way. Acceleration, also a vector. Will we ever talk about changing acceleration? No. You don't need to worry about acceleration that changes. Your acceleration will always be constant values. Okay? So here's my position time graph. A position time graph can tell me a lot of things. It doesn't matter if I'm looking at a constant velocity or a constant acceleration. The two graphs can tell me the same things. The slope for a position time graph, whether it's a straight line or a curvy line, the slope tells me velocity. A constant value velocity will give you a constant slope. A position time graph with acceleration means that you have changing velocity, which means that you have changing slope. At this point in time, the slope right here is an instantaneous velocity. Okay? At that instant in time, the slope tells me velocity. It changes because there's acceleration, which means I have a changing velocity, but at that instant in time, the velocity is the slope, yes?
And to find that, slope, what would you use for that?
Calculus.
That's not going to be on your test.
The concept will be on your test.
Okay.
For calculating it, you want some calculus. Okay? For now, you can find the slope of this one, right? Okay. And if I asked you to find the average velocity between here and here, then you would find the slope between there and there, because this is average velocity. Okay? The slope between 2 points is average velocity. With constant velocity, you only have one velocity, and that's equal to the average. It's equal to your initial. It's equal to your final. It's just a velocity. Okay, but with changing velocity, you can still find average velocity with slope. Just remember that the slope of a position time graph tells me velocity. Yes?
What is the constant?
Constant acceleration? Okay, the y-intercept will also tell me something important for a position time graph. On a position time graph, the y-intercept tells me initial position, which we abbreviate with a subscript, x sub I. Doesn't matter if I have a straight graph, doesn't matter if I have a curvy graph, the y-intercept tells me my initial position. Because that's your position at time 0, and that's how we define initial position. Okay? That is what a position time graph can tell you. Now with a straight line graph, we have one more thing that we can figure out. With a straight line, we know the equation of the line is mx plus b. Well, my y tells me position. So if I plug that in, then position is equal to the slope, which is average velocity, times the x-axis, which is time, plus my y-intercept, which is initial position. Okay, so with a straight line graph, I can find a formula for position at any point in time simply by plugging in what the slope and the y-intercept mean, what x and y mean. So if I wanted to know what the position was right here, and I didn't have a scale on this side, but I could figure out what the time was, then I can simply find the slope from velocity, the initial position as y-intercept, and I can calculate using that formula. You need to know why it's mx plus c and be able to substitute in the meanings of those? Yeah. But really, what's new here? You've seen y equals mx plus b. You've seen the fact that x and y can represent other things. The only really new thing is that slope is velocity and y-intercept is initial position. It's hard sometimes to integrate physics or another science class with the math knowledge you already have. But you already have almost all of this knowledge. Okay, the next kind of graph that we talked about that is also super important is the velocity time graph. When I have a constant velocity, which means my position time graph is a straight line, then my velocity time graph should indicate a constant value. Looks like that. Okay? When I have a constant acceleration, which means I have a curvy position time graph, then my velocity time graph should be a straight line. It should be linear. Not flat, but linear. It could be increasing. It could be decreasing. It could be increasing and negative. It could be decreasing and negative. Okay, all of those are possibilities. A negative velocity simply means that you're traveling in the negative direction. It's nothing more significant than an indication of direction. In the negative direction? Okay, now, when I'm talking about my velocity time graphs, the velocity time graph can tell me a lot of important things too. The slope on a velocity time graph tells me acceleration. The slope on a velocity time graph tells me acceleration. We will only ever talk about accelerations that are either 0 or constant. We'll never talk about changing acceleration. So your velocity time graph should always give you a straight line. If I ended up with a curvy velocity time graph, well then this would mean that acceleration was changing. Right? Because here, the slope is different than here, the slope. And that won't happen. We won't talk about this. Pretend it never happened. Okay? This graph shows a constant velocity. This graph shows a changing velocity but a constant acceleration because it's a straight line. The slope tells me acceleration. The y-intercept tells me initial velocity. I can write an equation for velocity at any point in time. These are both straight lines. Doesn't matter what graph I'm looking at here, they're straight lines. So if I apply my y equals mx plus b formula, and the fact that slope is acceleration and y-intercept is initial velocity, then I can say my velocity. Maybe I'm looking right here, maybe I'm looking right here, it doesn't matter where I'm looking. But my velocity is equal to the slope, which is acceleration, times the the x-axis, which is time, plus the y-intercept, which is initial velocity. Yes?
So the velocity is equal to average velocity or velocity?
Initial velocity.
No. What all that's equal to is velocity.
Velocity at whatever time I'm looking. So we would often call this final velocity, but it could be the velocity at 7 seconds. It could be the velocity at a second and a half. It could be the velocity at any point in time. Usually we've seen this formula with v sub f. Yeah.
Two questions. One is like for the second position time graph, like if it's since it's curved, would you still be able to use the y equals mx plus b
No.
form? Because you would be able to
You cannot use y equals mx plus b because it's